Okay, good morning, students. Today we will start our new topic from fourth unit. It is spin orbit interaction. Okay, as you all know about spin or orbit interaction in your atomic and molecular physics. Okay, so it's very easy to learn. There is no problem. Same topic it is. So what we are seeing spin orbit interaction means SPIN spin orbit interaction. Okay. So first of all, what is the meaning of spin orbit interaction? We all know actually the spin angular momentum. Okay. There is uh, because of the spin of the electron, there is one spin angular momentum. Okay. And for the orbital angular momentum because of orbital motion of the electron. So there are two types of angular momentum. Okay. Because of these two motions, there are two magnetic fields. Okay. Because electron is a charged particle, no. So when charged particle do a circular motion at that time, it create one magnetic field. It creates one magnetic field. Okay. So that there are we are seeing here the interaction of these two magnetic fields. Okay, na? So it means that the interaction of the interaction between the interaction between the orbital angular momentum and the spin angular momentum. Okay. So it is called spin orbit interaction. Okay, na? In simple words, we can explain as how a particle spin and how a particle spin angular momentum and orbital angular momentum interact with each other. Okay, na? Interact together. So it is called spin orbit coupling also. It is called spin orbit coupling. Okay, students. So it is an interaction between electron spin magnetic moment and internal magnetic moment or orbital angular momentum. Okay, na? Spin angular momentum and orbital angular momentum. So there is one magnetic field because of angular momentum is called mu s, and because of orbital angular momentum it is L. Okay, na? So we are seeing here LS coupling. LS coupling. Okay, students, are you getting me? Hello, students.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay. So first of all, we start with magnetic field. Okay, na? So which magnetic field we are giving here correspond to one electric field also. Suppose one electron is there, it is positive charge nucleus, and one electron is there which is moving around that positive charge with velocity v. Okay, na? With velocity v, and the electric field is here with E. So what is the relation between the magnetic field because of that electron and this electric field is V is equal to 1 by C into V cross E. Okay. So remember this relation V cross E. Now we know that P is equal to mv. So V is equal to what? P by m. Okay. So B is equal to 1 by C at the place of V. P by m we are putting here. So m is constant. So we are putting outside. It is P cross E. It is P cross E, equation 1. Okay, students. Now, for hydrogen atom, in hydrogen atom, electric field E is equal to what? Electric field E is equal to, we all know that grade phi. Some dynamics is here. Okay, but you have to just to see that it is in your degree also. Hydrogen atom, we have electric field. That electric field is always equal to grade phi. Okay, so that E is equal to grade phi. How can we write it? R divided by R means R vector divided by one point vector dou phi by dou R. Okay, it is equation 2. This is grade phi. Okay, this is grade phi. So now equation 1 and 2, what we are doing here, that E value we are putting in equation 1. That E value we are putting in equation 1. So B is equal to 1 by MC into P cross R by R dou phi by dou R. Okay. Now 1 by this R we can put outside MCR. That R also. Okay. So, sorry, not R. That dou phi by dou R. Dou phi by dou R. Okay. This gone, this gone. So only this is there. So P cross R. Okay. So when we want to write R cross P, then what we will do? R cross P, then what we will do? Minus sign is there. Minus 1 by MCR dou phi by dou R cross P. Okay. Now, what is that? It is B. It is magnetic field. Equation 3. Okay. Remember this equation. So, energy due to spin orbit interaction. Energy due to spin orbit interaction. Energy is what? Which energy? Hamiltonian energy. And equation is, sorry, interaction is there. So because of interaction, always perturbation is there. So we take perturbation term means H prime. Okay. H naught is what? H naught is Hamiltonian for unperturbed term. H prime is Hamiltonian for perturbed term. Okay. So for perturbed term, we are taking H prime is equal to mu s into B. This is the formula of energy. Okay. So now what we will do, that B, no, we are just calculated B, put that value in this equation. So what is our H prime? H prime is equal to one more. One thing is that I forgot to tell you that mu s, no, that mu s value is minus E by mc into s, minus E by mc into s. Okay, so it is here we put minus E by mc into s into what is the value? This b, this is minus 1 by mcr dou phi by dou r into r cross p. That minus minus plus. Okay, so h prime is equal to h prime is equal to E by that m square c square into 1 by r. I am writing separately dou phi by dou r into r cross p. Okay, students. So this is the energy of energy in frame of reference in which what? Electron is at rest position. Electron is at rest position. Okay, na? And one more equation, if we want to calculate the energy for the atom in which nucleus is the rest position. Okay, nucleus is the rest position. So what we will do, if we relate the transformation of normal frame of reference in which the nucleus is at rest position, so the energy is reduced at that time, reduced by factor 2. This energy reduced by factor 2 when we calculate for nucleus. Okay, it is for electron, it is for electron, and when we calculate for nucleus, so h prime is equal to E by 2m square c square into 1 by r dou phi by dou r cross p. Okay. This is for nucleus and this is for electron. It's a very important question, students. So please, one more thing is that this r cross p is, We are seeing here LS coupling, no? LS coupling we are seeing. So that R cross P is as L. That R cross P is L. Okay. So uh, and E by C, S is also there, no students? I forgot to write S here. See, S is also there. S is there. So S, then 1 by R separate, then dou phi by dou R, then R cross P. R cross P is L. So in last, what I can write, what we can write, E by M square C square into that S and L. So we can write 1 by R dou phi by dou R into L into S. LS coupling, so I am writing L and S. You can write S and L, anything. Okay, so this is your main formula. R cross P is denoted by capital L. This orbital angular momentum. Okay, students. Now, let's start fastly our next topic. It is very important topic, which is physical significance of non-degenerate perturbation theory. So, physical significance of non-degenerate perturbation theory. It is your second topic on your in your syllabus. Okay, and here and there the topic is, it is not physical significance. There the topic is um, application is that ground state of helium atom. Effect of electric field on the ground state of hydrogen atom. Effect of electric field on ground state of hydrogen atom. See in your syllabus, this is the topic. But here they are writing physical significance of non-degenerate perturbation theory. Okay. Physical significance of non-degenerate perturbation theory. Okay. In your exam you can see the topic like this also and that also, so don't be confused, both are same topics. Okay. So physical significance of non-degenerate perturbation theory. So what is the meaning of non-degenerate perturbation? Non-degenerate, okay, one degenerate and second one non-degenerate. I already told you about non-degenerate, that there is only one eigenfunction, so many eigenvalues, but related to all these eigenvalues, only one eigenfunction we get. Okay, so it is called non-degenerate function. Okay, now, so in corresponding to energy levels, so many energy levels, no, in atoms. So in corresponding to energy levels, eigenvalue are so many eigenvalues because energy levels are so many, but only one wave function is there. Okay, now, so then the system is known as non-degenerate system. Okay, student. Now, for example, we are taking here one helium atom. Suppose we are taking. So in helium atom, there is one nucleus. So two electrons revolving that nucleus. Two electrons. Okay. So they are revolving with. See here one. The distance of this electron from the nucleus is R1. The distance of this electron from the nucleus is R2. And the distance between these two electrons, the distance between these two electrons is R12. Okay. So here potential energy we are calculating first. Then what we have to calculate, actually I am telling that perturbed energy, which is denoted by W naught, and unperturbed energy, which is denoted by W naught, and perturbed energy, which is denoted by W prime. Sorry, W naught and W prime. Okay, so these two energies we have to calculate in this topic. Okay, students. So W, you know that Schrodinger wave equation, H psi is equal to E psi. Okay, but at the place of E, here we are taking W. So H psi is equal to W psi. Okay, both are same, just the symbol is changes here. So don't be confused, students. Okay. So now the potential energy first we are calculating, then total energy we have to calculate, then perturbed term and unperturbed term we will do separate and we will calculate. Okay. So potential energy for, it is denoted by V. That VR is equal to ZE into minus E divided by R1. It is for first one electron number 1. Okay. Plus ZE into minus E divided by R2, plus it is for second electron, then E square divided by R12. Okay, students. So solve it. VR is equal to ZE square. It is minus ZE square. Minus sign is there, so minus ZE square by R1 minus, sorry, minus ZE square by R2 plus E square by R12. It is equation 1. Okay, just to see what is happening here. Now total Hamiltonian. Total Hamiltonian means total energy. Total energy is equal to kinetic energy plus potential energy. Now kinetic energy is denoted by our Schrodinger wave equation, no, minus h cross square by 2m del square plus Vr, plus Vr is potential energy. Okay, student, it is equation 2. This is kinetic energy and this is potential energy. Hmm? Now, for two electrons, we have to see, no? For two electrons, what is Vr here? Vr is this. To put your Vr value in equation 2, how we will put here? See, for this, two electrons are there, no? So we have to write this term also for the two electrons. Okay. So it, it is H is equal to minus H cross square by 2m1 del 1 square for first electron minus H cross square by 2m2 del 2 square for second electron. Okay. Then again put the value of Vr, which is minus Ze square by R1 minus Ze square by R2 plus E square by R12. Okay, everything is clear from that point, student. Are you getting me? Understand?
Yes, ma'am.
Yes, ma'am.
Okay. Now the Hamiltonian is, this is no H. It is also H is equal to H naught plus H prime. H naught plus H prime. So first Schrodinger wave equation they are taking and then put the value in the form of this, okay. So how they are taking, H psi is equal to E psi, you know that. So we are taking H psi is equal to W psi. H psi is equal to W psi. Okay, students, now put their H value. It is there, no, this value in this. So minus H cross square by 2m1 del 1 square minus H cross square by 2m2 del 2 square minus Ze square by R1 minus Ze square by R2 plus E square by R12 whole psi is equal to W psi. Okay, students, now this term we are putting separate and this term we are putting separate here. Okay, so I am writing here minus H cross square by 2m1 del 1 square minus H cross square by 2m2 del 2 square, okay, minus Z square by R1 minus Z square by R2 into psi, okay, plus E square by R12 psi, okay, is equal to W psi. Now you can see that equation H psi is equal to W psi. Okay, in this equation we put. Now we come again to that equation. H is equal to H naught plus H prime. H naught is unperturbed Hamiltonian and H prime is perturbed Hamiltonian. So you can see in this equation, this is denoted by H naught, which is it is unperturbed Hamiltonian term, unperturbed energy shows this term, and this term shows perturbed energy. Okay, student. So here H naught is equal to this minus H cross square by 2m 1 del 1 square minus H cross square by 2m 2 del 2 square minus Z square by R1 minus Z square by R2. It is your H naught. Okay. Now H prime is what? Your H prime is what? H prime is E square by R E square by R1 2. This is your H prime. Okay. So now again that term that yes. So we get Hamiltonian now. Okay. Now what we will do? We again that this psi is also here, no? So psi naught is equal to psi naught 1 plus psi naught 2. Okay. Psi naught is equal to psi naught 1 plus psi naught 2, and your W naught is equal to also W naught 1 plus W naught 2. Okay, these two terms we have. Now what we will do, your H naught, no, here we are taking first unperturbed Hamiltonian, H naught W naught H naught psi naught H psi is equal to E psi, no. So H naught psi naught is equal to E. At the place of E we are taking W. So W naught psi naught. Okay, H naught psi naught is equal to W naught psi naught. So put a value of H from that, from here. This is your value of H naught. Okay. So put from here minus H cross square by 2m del 1 square minus H cross square by 2m, sorry, 2m1 here, 2m2 del 2 square. Okay. Uh, yes. Then the whole term, which is for whole H naught term. Okay. So what they are doing here, that they are taking first term for electron 1 only. First they are calculating for electron 1 only, then they are calculating for electron 2 only. Okay. So first for electron 1 from this equation. Which equation? Equation number 3. This is equation 3, student. Which is your first time writing, then I will do. First time writing here. Don't be confused. Okay. What is minus H cross square by 2m1 del 1 square minus H cross square by 2m2 del 2 square minus Z square by R1 minus Z square by R2 minus, sorry, not minus, whole psi, whole psi naught. Okay. Is there is psi naught, no? So H value I put H value, then psi naught is equal to W naught psi naught. Okay. Now for electron 1 we are separating the terms. For electron 2 we will separate the terms. Okay. So minus H cross square by 2m1 del 1 square is there, then minus Z square by R1. Okay. Here psi 1 also I am writing. psi 1 naught minus here also psi 1 naught is equal to W1 naught psi 1 naught. It is for equation for electron 1. Okay. So multiply with what? Multiply the above equation with minus 2m by h cross square. Means we don't want this term. Okay. So here when we multiply by this reverse, so it will cancel and we can get del 1 square psi 1 naught del 1 square psi 1 naught minus 2m by h cross square, because there is not that this term, no. So minus 2m by h cross square into z square by r1. Okay, z square by r1, and this term also we will take this side. So it is when we take, it is also in minus, no. When we take minus common, so it will plus. So plus w1 naught psi 1 naught is equal to 0. Okay, students. So here we are calculating W1 naught. We want W naught term first, then W dash. Okay, W dash or W prime. So when we similarly, okay, it is for electron 1, no, for electron 1. Now for electron 2, similarly I am writing direct here, del 2 square psi 2 naught minus 2m by h cross square z z square by r2 plus W2 naught psi 2 naught is equal to 0. Okay. Now what they are doing, that these are two equations are for hydrogen like wave functions. Okay now, and their solutions. These two equations, no. So the solutions of these equations are W1 naught is equal to sorry W1 naught is equal to W2 naught is equal to what? Minus z square by n square m e power 4 divided by 2 h cross square. This is the solution of these two equations. Okay. So Wn, they are writing W1, W2, W3 and so on. No? So Wn is equal to minus z square by n square into Wh. Okay. What is that Wh? Wh is equal to m e power 4 by 2 h cross square. Okay. So at the place of this term, we are writing Wh. And what is the meaning of Wh? It is the ground state energy for hydrogen. It is this Wh is ground state energy for hydrogen. Okay, students. Now W naught we calculated. Okay, W naught we have to calculate the total energy, total unperturbed energy. Total unperturbed energy means W naught is equal to W1 naught plus W2 naught. Okay, so W1 naught plus W2 naught. These both are same. Wn is here. W1 is equal to W2. No, see here. W1 is equal to W2. So both are same. This term is same. Okay. So here we can write the term W naught is equal to minus Z square by N square WH minus Z square by N square W. Okay. It is minus 2 Z square by N square W. What is that? It is W naught. Okay, students. So we calculated W naught. Now we want W prime. Okay, students. So it is for ground state, no? So we can put n is equal to 1 also. So at that time we get minus 2 z square WH also. Okay, minus 2 z square WH. Now it's very important term, which is perturbation term. Which is perturbation. Which perturbation? First order perturbation. Because H prime, no? So first order perturbation we will calculate. So H prime is equal to, already we know that E square by R12. Okay, from here. H prime is equal to E square by R12. H not we calculated. Now for W prime, we have to take this term. Okay. Now, what we will do, that WK prime is equal to, formula you all know, that integration of psi k naught star H prime psi k naught d tau. Okay, students, now H prime is equal to E square by R12. So WK prime is equal to integration of psi k naught star E square by R12 into psi k naught d tau. Okay, now psi star d tau, sorry, psi star is what? Psi star, psi is equal to mod psi square from your first unit. Okay, so here also WK prime is equal to integration of E square by R12 as it is mod psi square. So mod psi k naught is there, no? So mod psi k naught square d tau as. This is equation, next equation. Okay, we want this equation afterwards, because in this equation, if we want to calculate WK prime, no, W naught already we calculated. Now WK prime we are calculating here. So for calculating this, we want this value also, and this also. Okay, student. So for this, psi k naught is what? We have to first calculate this, then d tau. Okay. So psi k naught is what? Psi k naught is psi 1 naught and psi 2 naught. It is 1 is represent for first electron, and 2 is represent second electron. Okay, two electrons are there, because we are talking about helium atom. Okay, so for this, consider what? Consider A naught is constant, so A naught is equal to E is equal to 1. So first of all, what are these? These are value of psi k naught is equal to what? Psi k naught is equal to, see here, student, it is one formula which is in root of z cube by pi a naught cube. It is root of z cube by pi a naught cube, okay, into e power minus zr1 by a naught, e power minus zr1 by a naught. Okay, it is for psi 1. Now psi 2, again root of z cube by pi a naught cube into e power minus z r2 by a naught. Okay, r2 by a naught. So you can see here, root cancel. So psi k naught is equal to what we get? Z cube by pi a naught cube into e power minus, this a naught is 1, no? A naught is 1, so we can uh, remove this a naught. This is 1. So e power minus z r1 into e power minus z r2. Okay, student. Now psi k is there, but we want psi k square. Okay, psi k we calculated. When we square this term, then what happens? Then what we will get? Okay. So when we square that term, we will get mod psi k naught square is equal to z power 6 divided by pi square. Okay, and e power minus 2 z r1 and e power minus 2 z r2. Okay, when we square that term. Now put in that which equation in our the WK prime equation. WK prime equation is what? Integration of E square by R12 into psi mod psi k square, no? So we have mod psi k square this. So put z 6, z power 6 by pi square into e power minus 2 z r1 into e power minus 2 z r2 into what? Now d tau is there, no? So for we are calculating two electrons. So d tau is d tau 1 into d tau 2. It is converting in this. Okay, student, are you getting me? Just for after 2 3
Yes,
terms,
ma'am.
we will calculate this WK prime. Okay. So now for calculating all this, for calculating all this, they are consider R1 is equal to P1 by 2Z, R2 is equal to P2 by 2Z. Now dr1 is equal to what? dp1 by 2z, and dr2 is equal to dp2 by 2z. Okay. Now we know that r12 is equal to what? R1 minus R2. Like that, P1 minus P2 is equal to also P12. Okay. So P12 is equal to also P1 minus P2. Okay. So here we can write R12 R12 is equal to P12 by 2Z. Okay, R12 is equal to P12 by 2Z. How it is come? See here, put the value of R1, which is dP1 by which is R12 is equal to dP1 by 2Z minus dP2 by 2Z. Sorry, not dP. Sorry, we have to put R1 value. No, why we are putting dr1 value? R1 value is P1 by 2Z minus R2 value is P2 by 2Z. Okay. So what is R12 value? 1 by 2Z common. It is P1 minus P2. So P1 minus P2 is what? P12. So it is P12 divided by 2. Okay, student. Now, for these tau 1 and tau 2, for these tau 1 and tau 2, d tau 1 is equal to R1 square dr1 sin theta 1 d theta 1 d phi 1. Again, spherical polar coordinates they are taking. Okay, so for two electrons, one is for one electron it is, then other electron I will write afterwards. First we will calculate this. So d tau 1 is equal to r1 square means r1 is p1 by 2z, so p1 square by 2z whole square into what is dr1? Dr1 is dp1 by 2z. Okay, into sin theta 1 as it is, d theta 1 as it is, d phi 1 it is, sorry, d phi 1. Okay, it is d phi 1. Now for electron 2, when we calculate this whole term, when we calculate this whole term, we will get d tau 1 is equal to dp1 cube divided by 2z cube. Okay, student, this whole term I am not calculating here because it will take more time. So it is, you have to remember directly this equation, d tau 1 is equal to dp cube, dp1 cube by 2z cube. Like this d tau 2 also I am writing here directly dp2 cube by 2z cube. Okay. Now whole terms you have, whole terms you have to put just in the equation. Okay. So wk dash is equal to what? Wk dash is equal to, see here our all equations. Yes, this no integration of first, this is common I am putting because psi cannot in this term z power 6 by pi square constant no. So z power 6 by pi square I am putting constant. Then integration of e power minus p1 into e power minus p2 into 2z by r1 sorry p12 2z by p12 into the tau 1 tau 2. So tau 1 is dp1 cube by dp1 cube by 2z cube into dp2 cube by 2z. Okay, students, this is your WK day dash, and these all are constant values. Z is charge of proton, pi value you know, charge of electron you know. Okay, then distance is also you know. So if we put all these values in this above integration and integrate that, then WK dash value is 5 by 4 Z into W. 5 by 4 Z into WH. So you have W naught value, WK dash value. So we put in total energy formula, which is W is equal to W naught plus WK prime. You have W naught is what? Minus 2Z WH. Okay, already we calculated. And plus this 5 by 4 Z WH. When you put WH common, so it is minus also common, so it is 2Z minus 5 by 4, 5 by 4Z, 2Z minus 5 by 4Z to W. This is your W student total. Okay, this energy you have to calculate on. Okay, so we can calculate the energy values of like that helium now we calculated, like lithium also we can calculate, beryllium also we can calculate. Okay now, so many atoms we can calculate the energies like this. Okay, understood student?
Yes, ma'am.
Yes, ma'am.
Okay, if there is any problem so ask me. Okay, I will sort out. Now yesterday I will give you some problem you uh, did not that problem.
Yes,
Have you
ma'am.
done?
Yes, ma'am.
Okay.